Good morning, students. In our last class, we have discussed refraction in glass lab and also refraction in spherical surfaces. So today's class, we are going to discuss refraction in a prism. So in our class, we are going to discuss how refraction takes place in prism. Now, first consider one prism. A, B, C. So the angle of the prism is denoted by A. So this is one prism. Here BC is the base of the prism. BC is the base of the prism and A is the angle of prism. When a ray of light incident on the surface AB, so this is the incident light. So when a ray of light incident on the surface AB, if we draw the normal at the point of incidence to the surface AB, like this. So this becomes the normal. So this normal, the angle between the incident ray and to the normal will be taken as angle of incidence. So this one P and here it is Q. PQ is the incident ray and the normal N1 and N. So N1 or N dash N is the normal to the face AB. I'm taking here N1. When the light travels from rarer medium to the denser medium, here the prism is taken as glass. So from air medium to glass medium, that is the light travels from rarer medium to denser medium, the refracted ray is bent towards the normal like this. So this one is the refracted ray and the refracted ray makes the angle with the normal, that one we taken as angle of refraction. This refracted ray strikes the surface AC at point R. So this QR is the refracted ray at the first surface. This refracted ray QR behaves as the incident ray for the second surface, that is for the surface AC. So QR is the incident ray for the second surface and the light travels from denser medium to the rarer medium. If I draw the normal at point R, so this is the normal, I call this one as N2. So N2, N is the normal to the surface AC at point of incidence is R. As the light travels from denser medium to the rarer medium, the refracted ray is bent away from the normal. So this is the refracted ray which is bends away from the normal. So this ray we call as emergent ray. So that's why the angle we taken as E, emergent angle. Here is the incident angle and here is the emergent angle. So this one as S. So if the light incidence, when the light incidence on the first phase, that is PQ is the incident ray and the light travels from rarer to the denser medium. So the refracted ray is bent towards the normal. This refracted ray acts as the incident ray for the second surface, that is for the surface AC. As the light travels from denser to the rarer medium, the refracted ray is bent away from the normal, that is RS is the emergent ray. So if we write here this A is the angle of prism. Next PQ is the incident ray. PQ is the incident ray, QR is the refracted ray, next RS is the emergent ray. Next, I is the angle of incidence. I is the angle of incidence, and here is the R1. R1 is the angle of refraction at first surface, at angle of refraction at surface AB, and here is the AB mean, here is angle R2. So here R2 acts as the angle of refraction at AC, and E is the emergent angle. Considering N as the refractive index of the glass, N as the refractive index of the prism, that is glass prism. So N is the refractive index of the prism. So these are the terminologies. Here we are going to observe. So N1 N is the normal to the first surface AB, and N2 N is the normal to the second surface AC. Next is the angle of deviation. So if we extend the incident ray like this and extend the refracted ray, that is emergent ray, so this angle we have deviation angle, that is delta, where delta is the angle of deviation. Here delta is the angle of deviation or deviation angle, that is the angle between the emergent ray and to the extended incident ray. That angle called as angle of deviation. So it is denoted by delta. So delta is the angle of deviation, that is the angle between the emergent ray RS and to the extended incident ray, that is PQ. That angle we call as angle of deviation. Next, if we observe here, we have one quadrilateral, that is A, Q, N and R. From quadrilateral A, Q, N, R, here we have N1 N, that is N1 N is normal to the surface AB, and N2 N is the normal to the surface AC. Here the angle is 90 degree. So here the angle will, that is angle between A, Q, N is 90 degree, and the angle A, R, N is 90 degree. So from this quadrilateral we have two angles is 90 degree. That is, if we write this quadrilateral, we get like here. A, Q, N and R. So this angle is 90 degree and this angle is 90 degree. So quadrilateral, the sum of the angle is 360 degree. So here we have the angle A, and if these two angles are 90 degree, then remaining opposite angles, that is angle A plus angle Q, N, R, that is equals to 180 degree. Here 90 plus 90 is 180. So the remaining angle is A plus N, that is angle A plus angle N, that is equals to 180 degree. If you call this one as first one. Next, considering the triangle, from triangle Q, N, R. Considering the triangle QNR, if we draw this one like this is Q, N and R. So this angle is R1 and this angle is R2. So the sum of the angles in a triangle that is equals to 180 degrees, that is R1 plus R2 plus angle QNR, that is equals to 180 degree. This one as second equation. So if we observe first equation and second equation, the RHS terms of these two equations are same, then we can equate LHS of these two equations. So if I equate these two equations, that is from equation 1 and 2, from equation 1 and 2, that is A plus angle QNR, that is equals to R1 plus R2 plus angle QNR. In LHS and RHS we have the same terms, angle QNR and angle QNR. It gets cancelled, so the remaining we get A is equals to R1 plus R2. This we taken as equation third. So A is equals to R1 plus R2 from equation 1 and 2. Next, the total deviation. Here is the deviation angle delta, that is total deviation. Total deviation, that is equals to sum of the deviations that takes place at two surfaces. This is the first surface AB. Here we have the deviation, and at the surface AC we also have one deviation. So this is the deviation. This angle is the deviated angle, and here also we have the deviated angle. If you consider as delta 1, delta 2. So the total deviation delta is equals to sum of the deviations of two faces, that is delta 1 plus delta 2. So if we observe here, angle I, that is equals to delta 1 plus R1. Angle I, that is equals to R1 plus delta 1. We need delta 1, that's why delta 1 is equals to I minus R1. If we observe here, we get emergent angle E, that is equals to delta 2 plus R2. Delta 2 plus R2. We need delta 2. So delta 2 is equals to E minus R2. If we substitute these two values, delta 1 and delta 2, we get the total deviation delta. In place of delta 1, I will write I minus R1 plus, in place of delta 2, I will write E minus R2. So if we rearrange this one, I plus E minus R1 minus R2, that is equals to I plus E. If we take minus common, here we get R1 plus R2. So from equation 3, we have R1 plus R2, that is equals to angle I plus E minus A. So this is the deviation angle delta is equals to I plus E minus A. So I will take this one as equation 4. Next, the condition for minimum deviation. The condition for minimum deviation. Condition for minimum deviation. for minimum deviation, the refracted rays inside the prism has to become parallel to the base of the prism. Then the angle I is equals to angle E, and also angle R1 is equals to angle R2. So if I observe, if we write the condition for the minimum deviation, so this is the incident ray, refracted ray, and this one is the emergent ray. So this is A, B, C. Here is the angle A, P, Q, R, and S. So if I draw the normal here, N2 and N1. So if we observe these two diagrams, here the refracted ray is not parallel to the base. So here we need the condition for minimum deviation. So the condition for minimum deviation, the refracted ray inside the prism. So this refracted ray must be equals to the base of the prism. Then the angle of incidence I is equals to the angle of emergence. Angle of incidence I is equals to the angle of emergence, and also the angle of refraction R1 is equals to the angle of refraction R2. That is here R1 is equals to R2. So this is the condition for minimum deviation. The condition for the minimum deviation is the angle of incidence is equals to the emergent angle, and the refraction angle R1 is equals to the refraction angle R2. It has to be follow the conditions, means the refracted ray must be parallel to the BC. That is QR is parallel to BC. So if we substitute these values in the equation 3 and 4, that is R1 is equals to R2. In common we can take R plus R, then A is equals to 2R, then R angle of refraction is equals to A divided by 2. If we apply same here, angle of incidence is equals to angle of emergence, that is I. In place of E, I will write I minus A. That is equals to I minus A. So here for the minimum deviation, the delta becomes dm. That is minimum deviation. Delta can written as dm. So here I will write dm. So I need angle of incidence I will shift it to RHS, then it becomes I is equals to A plus dm divided by 2. So this is the angle of incidence I. Here N is the refractive index of the prism. Then from Snell's law, from Snell's law, refractive index of the medium, that is equals to sin I by sin R. We have the value of I and we have the value of R. We substitute here, we get N is equals to sin of A plus dm divided by 2 whole divided by sin of A divided by 2. So this is the refractive index of the prism. So this formula we call as prism formula. So this formula we call as prism formula. So this is the derivation which we have studied in the concept refraction through a prism or refraction in a prism. So it is very important for 5 marks. So in this chapter, we get nearly 4 to 5 derivations. In the derivation, refraction in a prism, they ask for derive the formula n is equals to sin of a plus dm by 2 whole divided by sin of a by 2, or refraction in a prism, or derive the prism formula. They will ask for 5 marks. So it is also the very important derivation. We have to work out on this derivation. If we write any one of the diagrams for the examination, for understanding purpose, I will explain by using the two diagrams. The main is the condition for the minimum deviation. The condition for the minimum deviation, that is angle of incidence is equals to angle of emergence, and the refraction, angle of refraction at first phase is equals to angle of refraction at the second phase. Then we call delta is equals to minimum deviation dm. So this is the relation, that is refractive index and to the minimum deviation angle dm. So this formula we call as prism formula. So next, for thin prism, for thin prism, for thin prism, the angles we are taken is almost equal, that is small angles. That is for considering this one as a thin prism. Then for small angles, the prism formula becomes n is equals to the sine of a plus d by 2 is equals to a plus dm by 2 whole divided, that is sin theta is approximately equal to theta. Like that, we can write sin of a plus dm by 2 is approximately equal to a plus dm by 2, and in the denominator it becomes a divided by 2. So if we cross multiply here, n into a divided by 2, that is equals to a plus dm by 2. In LHS and RHS we have the common term 2, so we can cancel. If we shift, we need the minimum deviation angle dm. If we shift a to the LHS, or if we shift the LHS term to RHS, we get dm, that is equals to na minus a, that is deviation, minimum deviation angle dm, that is equals to n minus 1 into a. Or if we write medium of second medium with respect to first medium, if we consider this medium as 2 and here the air medium as 1, then it becomes n to 1 minus 1 into a. So this is the minimum deviation angle. If I write in this diagram, that is the angle between emergent ray and to the extended incident ray, then this angle is minimum deviation angle, that is dm. Considering thin prisms, for thin prisms the angles will be very small, then the relation, the prism formula becomes n is equals to a plus dm by 2 whole divided by a by 2. So if we rearrange the terms and simplify, we get dm is equals to refractive index minus 1 into a, that is minimum deviation angle. Minimum deviation angle. So this is about the refraction in a prism. We have the derivation, that is we have to find out the prism formula. We have to derive the prism formula, which is n is equals to sin of a plus dm by 2 whole divided by sin of a by 2, and here the deviation angle dm that is minimum deviation angle. So this case is valid when the refracted ray inside the prism is equals to the base of the prism, that is angle of incidence is equals to angle of emergence, and angle of refraction R1 is equals to angle of refraction R2. At that case only we get the minimum deviation, and the minimum deviation angle we taken dm is equals to n21 minus 1 into a. If we plot the graph for minimum deviation, so this is along x-axis, it is angle of incidence, that is I, and in y-axis we have angle of deviation, that is delta. If you plot the graph here, we get like this. At this point, delta is equals to angle of incidence I is equals to angle of emergence, here delta is equals to d here. So after the derivation, we have to plot the graph like this. Then only the derivation will complete. So along y-axis we taken as angle of the deviation delta, and along x-axis we taken angle of incidence I. So if you plot the graph, it will form like this. At the bottom point, at the least point, we get at angle of incidence I is equals to angle of emergence. If we taken or extended along y-axis, then it becomes the minimum deviation angle. After that, it won't deviate. So this is about the refraction in a prism. So next, we will solve few problems on this concept. So we take one problem. A prism of angle 60 degree, a prism of angle 60 degree produces angle of minimum deviation, produces angle of minimum deviation. A prism of angle 60 degree produces angle of minimum deviation of 40 degree. What is refractive? What is its refractive index? And calculate the angle of incidence. Calculate the angle of incidence. So here given the prism angle. So the given is in the question the given angle of prism is 60 degree. It produces the angle of minimum deviation of 40 degree. That is minimum deviation. That is dm. That is equals to 40 degree. We have to calculate what is its refractive index. That is n. We have to calculate its refractive index, and also we have to calculate the angle of incidence I. From the prism formula, we know n is equals to sine of a plus dm divided by 2 whole divided by sine of a by 2. So this is the prism formula. By using this formula, here the given angle of prism and minimum deviation angle, then we can easily find out the refractive index of the prism. That is n is equals to sine of angle of the prism is 60 degree plus minimum deviation angle is 40 degree, that is divided by 2. In the denominator we have only the angle of prism, that is 60 divided by 2. If we simplify here, 60 plus sine of 60 plus 40 is 100, 100 divided by 2 is 50, that is sine 50 divided by sine 60 divided by 2 is sine 30. From the log table, if we find the value of sine 50, we get 0.766 divided by the value of sine 30 is 1 by 2. 1 by 2. If the 2 goes to the numerator, then we get the refractive index, that is n is equals to 2 into 0.766 into 2. So the refractive index of the glass 0.766 into 2, that is equals to 1.53. That is equals to 1.53. So this one is the first one, the refractive index by using the prism formula. Next, we have to calculate the angle of incidence I. In the prism formula, that is we are using the Snell's law, that is sin I by sin R. In case of I, we return a plus dm by 2. Then we can equate I is equals to a plus dm divided by 2. That is equals to angle A is 60 plus minimum deviation angle is 40. So it becomes angle of incidence is 50 degree. So the angle of incidence we calculated is 50 degree. By using the prism formula, we can easily simplify the problems. So next, second problem. An equilateral prism of glass, the given its refractive index is 1.6, that is n is equals to 1.6, is immersed in water. The given water refractive index n is equals to 1.33. Calculate the angle of deviation. Calculate the angle of deviation produced for a ray of incident light at 40 degree on one face of prism. So in this question, they are not mentioning the minimum deviation. We have to calculate the deviation, that is delta. We have to calculate the delta deviation produced by the ray of incident light. They given they mention equilateral prism. So equilateral prism means all angles are equal. Then the angle A is equals to 60 degree. Next, angle of deviation we have to find. The given angle of, that is refractive index of glass, that is Mg, that is equals to 1.6, and refractive index of water, that is Nw, that is 1.33, and the given the angle of incidence I is equals to 40 degree. In the last derivation, we have the formula deviation delta, that is equals to I plus E minus A. Here we know A value and we know the I value, but we don't know the angle of emergence. So we have to calculate that angle of emergence. So to find, we have to find the deviation delta. So first, considering the surface AB, here we get the angle of incidence, that is from the light ray travel from first medium, that is here in the question they given the water medium and the prism as glass. So here we have water and here we have glass, that is from rarer to denser, because the refractive index of water is less than the refractive index of the glass. As the light ray travels from rarer medium to the denser medium, if we apply the Snell's law, then we get Mg by Nw, that is equals to sin I divided by sin R1. In this relation, that is applying Snell's law at face or at surface AB. So at this face AB, we are applying this Snell's law. Refractive index of the second medium with respect to the first medium, Mg divided by Nw, that is equals to sine of incident angle to the sine of angle of refraction, that is R1. In this equation, we know the value of refractive index of glass, refractive index of water, and also the angle of incidence. Then we can find out the angle of refraction R1. So we have Mg is 1.6, 1.33, that is equals to sine 40 degree by sine R1. So sine R1 is equals to, if we see, or we can take the value of sine 40 degree from the log book, then its value is 0.648 into 1.33 divided by 1.6. Then if we simplify, we get the value 0.5343. If we simplify this one, we get the value 0.5343. We need angle of refraction R1, then R1 is equals to sine inverse of 0.5343. Then we get R1 is equals to 32 degree. The R1 is equals to 32 degree. From derivation, we know A is equals to R1 plus R2. We know the angle of prism, that is 60 degree. Just now we calculate the angle of refraction R1, that is 32 degree plus R2. From this, R2 is equals to 60 degree minus 32 degree. Then here we get R2 is equals to 28 degree. Next, applying Snell's law at the second surface, that is to the surface AC, then Ng by Nw is equals to sine E by sine R2. We know these values, that is 1.6 divided by 1.33, that is equals to sine E divided by sine 28 degree. So if we rearrange, sine E is equals to 1.6 divided by 1.33 into sine 28 degree. So sine 28 degree is 0.4648. 1.6 divided by 1.33 into 0.4648. If we simplify this one, we get 0.5591. 0.5591, that is sine E is equals to sine inverse of 0.5591. Then its angle of emergence E is equals to 34 degree. So that is approximately equals to 34 degree. Now we substitute the value. We already know the angle of incidence and also the angle of prism. Now we find out the value of emergence, that is 34 degree. If we substitute here, we get the deviation angle delta. When we substitute here, delta is equals to I plus E minus A. 40 plus 34 minus 60, that is 74 minus 60. The angle of deviation is 14 degree. So this is the final answer we get. In the next class, we will discuss about some natural phenomenon that takes place by the sunlight. Thank you.